everyone. My name is Stephanie, and I'm here today to talk to you about data quality, what it is, why it matters, and how you could learn some more yourself. As big data becomes used in every industry to drive so many decisions, the quality of data is going to become ever more important. So this is a topic that has been really exciting for me to learn about at work, but hopefully also will apply to wherever you are in your careers or projects that you'll be working on. So just to start, a little bit about me. I graduated from Washington University in St. Louis in 2017 with degrees in computer science and systems engineering. While I was there, I interned at a management and tech consulting firm called Advanced Technology Group, where I learned about tons of different kinds of problems that people face in industry as software engineers. And then after that, I started a small company called Check the Queue that makes airport management software. And for the last 2 years, I've been working as a software engineer at 2 Sigma out of the New York City office. So just before I start, a little disclaimer, since I work at a financial services company, this presentation will contain no financial advice. It's all just for information purposes. So what is 2 Sigma? 2 Sigma is an investment management company that manages over $50 billion. And we're headquartered out of New York City, but we also have an office that's not too far from here. There's about 1,500 people so far at the company, and it's really rapidly growing. There's actually a booth outside if you'd like to learn any more. And just for an overview of what we do, we ingest a ton of data every day. We ingest about a petabyte of data, which is 1,000 gigabytes every day on all different kinds of topics. So when you think of financial services, you might think of things like financial filing information by companies, but we look at all different kinds of data too, like user-generated content and data sets on all sorts of topics. And then we take that data and we use it to build out models of market forces and what we think will happen. And then we use those models in order to trade intelligently to manage that money. So when would data quality matter? I personally think data quality matters anytime you're making a decision off of data, whether that's in your personal life, on a project, or as a company. And it can matter for a lot of reasons. So for us at 2 Sigma, we use data in order to make good investment decisions. So if we didn't have really high quality data, we might be missing out on potential market opportunities. But it could also matter in a field like public health. Let's say you were looking at public health data sets in order to determine where to send vaccines or medication or supplies to a certain area. If you didn't have a high quality data set, you might send the wrong number of supplies or send it to the wrong place entirely. Maybe weather data is something that really matters to you. Have you ever woken up in the morning, gotten dressed, gone outside, ready to start your day, and all of a sudden it rained and you weren't expecting it? That really sucks. And so having high quality weather data can just matter in your everyday life too. Also in transportation, have you ever been bothered by a delayed flight or a train that's not on the right schedule? It's really hard to make those predictions around scheduling when you don't know what weather forces might come up, or maybe there's unexpected delays, like boarding takes longer and your model on boarding isn't quite correct. So if you don't have high quality data sets, you're not going to have right models that are being used to schedule things like transportation. And lastly, as a final example, in retail, there is tons of data that's being used to drive product decisions. So data is being tracked on who enters stores, what types of products they buy, where they are in the store, and that's being used to determine how long to keep products out on shelves, what products to roll out, how to do marketing strategies. And so it's really important for the profitability of stores as well. So let's take a really fake example of something we would do at 2 Sigma so you can get a better understanding of how and why the quality of that data might matter. So let's say that we can use weather data to predict the stock prices of certain companies. Maybe before a huge rainstorm, umbrella company stocks go soaring, or before a super sunny weekend, sunscreen store companies might be doing really well. And so this is just a really fake, simple example, but gives you an idea of how we could be using a particular data set to drive a decision and why we would care about the quality of that data set. So let's say that this data set is really tiny. There's just a few data points, and it's small enough that we can look at it with our own eyes. When we're looking through this data set, what kinds of things would we look for in order to say, yes, this weather data set we're using, it's really high quality, and we can base our decisions off of it? Well, we might look for things like missing data points. Let's say we get in data at an hourly schedule, and then all of a sudden we're missing a whole day's worth of data. Maybe we're making our decisions based on really stale data, and that wouldn't be good. But we can also look for things in the actual data points themselves, like invalid data. Maybe if we're looking at this data set, we see that it records the temperature in London as 90 degrees for a day. When you see that, you realize something must be wrong there. And so you can flag this as maybe the data set has other issues. But sometimes the context is really important. Let's say it says it's 25 degrees for a day in London. Is that accurate? Not if it's January. So we can use that context to determine that maybe something here is wrong. Maybe there was a sensor we're relying on that's been emitting the same value from the summer, and then we can further investigate this data set to see, is it actually safe to use? Something else that's really important is the consistency of the data we're working with. So if we want to be absolutely sure that the data we're using is really good to use, maybe we can take a few different data sets. We can compare those data sets and see, do they tell a similar story? Is there something going on here that we wouldn't expect? If we have 10 data sets around weather, and 9 of them have the same value for a certain point, and that 10th one doesn't, that's kind of a red flag that maybe something's going on with that 10th data set that we could look into. But comparing across data sets can be really hard. Let's say 8 of those data sets put all of their data points in terms of latitude and longitude coordinates, and the other 2 put them as street addresses. It can be really hard to line up that data to see, do they agree or do they not? And this is a problem that's faced in things that isn't weather data as well, whether it's comparing zip codes or comparing people. Say you have a system that manages contacts. Are those names the same? If there's a typo, did someone just put it in wrong? Maybe those are different records. So this is a problem that comes up a lot as you try and use multiple data sets to figure out a better story. So we have a few different potential approaches. Many of these we take at 2 Sigma in various forms, but I'm going to talk a little bit about what happens when that data set isn't so small that you can look at every row yourself. How would you go about making some of these assertions on a really large data set? The first one might be, as engineers, you're like, ooh, I can just code up some assumptions. I'm an engineer, I can write some if statements, and then if things come out from that, then I'll know that something is wrong. So maybe going back to my really small data example, I have just a few rows of some London data and some data from Antarctica. Well, I can look at the London data and say, this, as someone who knows London, is what I would expect to hold true. But how do I do that for Antarctica? It seems really challenging. Would I say that 10 degrees is the highest I'd expect? Is it 15, 20? I have no idea. So I really need someone else's input who understands the data to help me write this check. Can't just do it on my own. So you might be thinking, all right, well, you can't, as a human, realize when something is weird, but maybe a machine can look at the data for the last year or two and see when something is atypical. Maybe you can use some machine learning approaches to understand when data seems weird. Kind of a funny story to explain why you can't do this. There's someone at 2 Sigma named Ben Wellington, and he has a blog called iQuant New York. And what he does, he goes around and looks at open data sets by the city of New York to find anomalous data. And the reason he does that is that anomalous data is often correct data and tells a really interesting story. So he found an example of a data set that gave the parking violations around the city of New York, and he found that one parking spot was making over $30,000 a year, which was really atypical. So if a machine were looking at this data set, it might say, okay, I found an error, let's take this out of the data set, this shouldn't be here, we'll flag it as bad data. But Ben, as a human, was able to actually go to that parking spot, visit it in person, and say, oh, I get it. This parking labeling is extremely confusing. So when he was there in person, he realized why this was happening, that this is correct data, but there's an underlying world problem for why it's happening. And so the city of New York actually went back and repainted the parking spot to make it clearer. Another cool example that he found is that around rush hour time, there was a huge peak in the number of people who tip 21% in taxi cabs, which is a very weird number. It's not the default option, and it wasn't happening all the time or everywhere. And so something that he realized is that a certain software that's used not in all the taxis, but some of them, calculate tip differently. And so this is just a couple of silly examples from New York to explain why machines can't always just look at data and see things that are weird and rule it out, because sometimes anomalous data is correct and has a real-world example to explain why it's happening that way. Okay, so if I can't do it, and the machines can't do it, then we need some kind of collaborative system where maybe I can build the system that takes in these rules, and I can work with domain experts who understand the data and can help to author these checks of what they would expect to hold true on the data. So we went about this by constructing a diagram that looks like this to understand what we wanted to do to capture these checks and run them on an ongoing basis. We ingest data from lots of different places and store them in-house at 2 Sigma. And then we get them on weird schedules. So some things come every minute. Some things come every day or every hour. And we want to be able to check as we get them, are those things okay, so that they can be used in downstream processes. So we need a check that we can run on this data at whatever schedule that file comes into. So this is something that as engineers, we can build completely ourselves without domain experts. We can build a scheduling system, we can build file ingestion system, and we can export the rows that don't meet these checks into a certain place. And the reason these are labeled as suspicious rows is that they might not be errors. If we go back to the example that I had with the Antarctica data, sometimes your thresholds are wrong. Sometimes the domain experts might say, actually looking at this data, it's correct, and I need to refine my check. Or maybe they'll look at these rows and say, oh yeah, something's wrong with that, and there's an action I need to do to investigate, to confirm if the error is actually there, maybe go back and correct the data set. So we need some system that allows us to get that domain experts' check and their thoughts into the system. So that big purple box is kind of the thing that we were missing here. How do we get their thoughts and put it into code? And then we need to take the results of those checks and use that to feed the checks as like a continuous loop. As they realize, maybe the thresholds weren't right and they need to refine the checks, then we can do this as an iterative process. So with that big purple box, we were left with a question. Should we build out something to get their ideas, or should we buy a system for that? And this is a problem that we face a lot as software engineers. There's tons of problems where maybe it's been solved before, and you have to figure out, can you do it better differently? Maybe that's a waste of time. Maybe you're just reinventing the wheel. So there's a few factors that we use to make this decision. Did we have the time to build out something like this, or were there other really high-value projects that we needed to work on instead? Customization is a big one. Could we use things that are off the shelf, or was our use case somehow slightly different than everyone else's, and would we need a slightly custom-built product? Cost, always a big one. Can you afford the cost of the software that's out there? Is there a good option at a reasonable price? Is there one for sale even at all? Is a big question to ask. In-house expertise. We needed to build something that would be really easy for these users to interact with. We were envisioning something drag and drop, something that non-engineers could use as well. And so we might not necessarily have the expertise to know the best way to do this, as we haven't seen it done in lots of places. So often in open source or other areas, these companies have tried out products, people have contributed to them, refined them, asked questions, and helped them grow over time. And that's an expertise that we didn't currently have in-house. And support. Would we have the bandwidth internally to continue to support this product that we build long term? Or can we utilize something that's already there that has a community behind it, answering questions and fixing bugs and helping to contribute new features? So in order to make this decision, we had to look at all the things that are currently out there. One of the places that we often go to is called Gartner. They are a giant research firm that can help point you towards a lot of options that currently exist, and just some thorough Googling will give you lots of examples that are out there. And so out of this huge variety, we demoed a bunch of products, and we're currently in the evaluation phase of trying out Talon to use for that big purple box we saw in the diagram earlier. The way this ends up looking is that when you use a product like Talon, you can say how your file looks like. So we can say with this weather data, here are the columns we expect. We expect a temperature column, we expect a latitude and longitude points. And this is something that the domain expert knows. What's in the data, what format it should have, do the dates have slashes, do they have dates, what should things look like? And then they can visually draw this check that they have in mind. So maybe they want to bring in 2 different weather data sets to compare and see what things don't look right. So they might aggregate these and map them together, saying latitude, longitude points that are within a certain distance from each other, that's considered the same data. We can count that as one row. And then we can find things that look anomalous. Maybe if the temperature varies from one day to the next by more than 5 degrees Celsius, that's really atypical, and so we want to see that. maybe if the pressure in the atmosphere changes drastically from 1 hour to the next, that's also atypical. Or going back to our examples earlier, data that's just flat out wrong, like 90 degrees Celsius in London, or wrong temperatures for the wrong time of year. So as someone who understands the data, they can help author this. And then Talend, or a system that's used instead of it, will be used to generate code that we as engineers can run on a schedule that we choose. So if we look at a simple example of things changing over time, we can look at different rows, and as they put this in business logic, we can get code that looks somewhat similar to this that we can run on an ongoing basis. So that we can run this check on the schedule we choose, and the domain experts can see the data that's flagged. So just to summarize what we talked about so far, data quality is really important, and it's going to become ever more important as we start to use big data sets to drive decisions in all sorts of different industries. But not all data can be looked at as a human. Giant data sets are just not possible for everyone to read through. And machines are not perfect at identifying errors. So we need some collaborative system that allows domain experts to give their thoughts on what the data should conform to, as well as run automatic checks. So if you're curious to learn a little bit more about this for yourself, about how you can get started analyzing data quality and making data quality assumptions, there's some really great resources that you can use. Kaggle is a resource that's provided by Google, and they have tons of data sets. So you can browse around and download data sets for yourself. But they also have really great data science competitions if you're interested in trying out some, with some really fun prizes. London, the City of London, also has really fun open data sets. So you can find data sets from all different places all around the world, but with London, you might be an expert yourself. You might be able to make assumptions of things that hold true. I'm from New York City, and when I was looking at the data around trash cans, it sounds very obscure, but it was really fun because I recognized the trash cans I saw on my way to work, and that's something that I can make assumptions about. I know how often they're on the street. I know where they are. And so you can find something similar that you might know about with the City of London. And lastly, you can try and actually write some code yourself. You can import the data sets that you find into a Jupyter notebook and write some Python. See what kind of weird data that you can find. So thank you so much, and with that, I'll answer any questions.